Okay, this is group A16 of the EECS 203 winter 2012 class. This is a video on the division rule as it pertains to counting, and this is on noatom.com. My name is Steve.
I'm Robbie.
I'm Eric.
And our scriptwriter Paul is out of the studio right now. So moving into the video. As it says in our textbook, the division rule states that there are n over d ways to do a task if it can be done using a procedure that can be carried out in n ways, and for every way w, exactly d of those n ways correspond to the way w. But really, that doesn't make sense to me. I can't even really comprehend what it means.
Yo, you know what? I got a better way. Let's explain it in a function. Alright, let's try that. So, words, I'm not good with that. Also, with functions, I think I can explain it. First, let's do a function from A to B. F is a function from A to B, and then x, I said for every y value, there's y1 and y2 in set B, and there's x1, x2, x3, x4 in set A. Now, from y1, okay, so y1, for every y1, there are exactly 2 x that are in set A that correspond to y. That makes f of x equals y. And d, in this case, equals 2. So what I'm saying is that for every value y that is in set B, there are exactly d ways, x in set A. So, example, in set A, there's 4 elements. In set B, there's 2 elements, y1 and y2. Now, we know that the cardinality of B would be 2 because there's 2 elements. Cardinality of A would be 4. And it is easy to tell us that cardinality of B is equal to cardinality of A over D, which D equals 2. So, with the functions, I have already explained the division rule.
Well, that makes sense to me, Eric, but I'm a simple-minded guy. I like to see pictures and colors. Do you think that there's even a better way to do it?
Yes, there is, in fact.
Really?
There is a way called the tree rule, tree method, tree diagrams, things. And they go a little something like this. Now, let's say that we are making a bit string composed of 1s and 0s. And we're going to make a bit string of length of 3 different bits. Now, the first bit we can choose is either a 1 or a 0, like so. Now, choose the second one, after we do 1, we have 2 more options. We can put another 1 at the end and another 0 or a 0 at the end. And the same goes with the string that we started out with, the 0. And to go once more, we can go 1, 1, 1 and 1, 1, 0. We could go 1, 0, 1 and 1, 0, 0. 0, 1, 1, 0, 1, 0, 0, 0, 1, and 0, 0, 0. Now, a tree diagram is like the roots of a tree. You start at the central point, which is the base of the trunk, and you branch out through all the possibilities that can happen at each step. So in the end, we get 1, 2, 3, 4, 5, 6, 7, 8 different options for a bit string consisting of 3 digits. Now, for a bit more practical way of using tree diagrams is, well, sports and playoffs. Now, spring training just started, and, well, I kind of like baseball, so I kind of base this example off baseball. Let's say that the Tigers and some other team that begins with a Y decided to have a best 2 of 3 series. Now, the first game, you have the option of either Tigers winning or the Yankees winning. And then, if the Tigers win, you have 2 more options there, the Tigers or the Yankees to win. Now, since the Tigers have won 2, that ends this branch with 2 straight Tigers wins. And the same goes for the other end, only this time with 2 straight Yankees wins. Now when you got Tigers-Yankees or Yankees-Tigers, you got one more game to play, so you can have any of these options in Game 3. You can have Tigers-Yankees-Tigers, Tigers-Yankees-Yankees, Yankees-Tigers-Tigers, or Yankees-Tigers-Yankees. So there are 1, 2, 3, 4, 5, 6 different ways that this playoff series can go. Yeah. To watch more discrete mathematics videos, you can go to...
Actually, Robbie,
yes?
That's really good. I like your way. Tree methods is just so pictorial and easy to understand, but I have to give credit to explaining function. So we all know more about division rule right now. If you're exceptionally smart, wording is also a good way to understand. So this is our group, A16, presenting division rule. I hope you enjoy.
If you want to see more discrete mathematics videos, head over to knoatom.com, spelled Knoatom.com.
Cool.